Understand the core analytical concept. Beer's law. The graph provided is a calibration curve that relates the absorbance A of the dark red coordination complex FeSCN to the power 2 plus to its molar concentration, M, at a specific wavelength, 453 nanometers. According to the Beer-Lambert law, absorbance is directly proportional to concentration, A equals epsilon BC, yielding a straight line of best fit passing through the origin. Read the concentration of FeSCN to the power 2 plus from the best fit line. Locate 0.20 on the y-axis. Absorbance at 453 nanometers. Follow the grid line horizontally to the right until it intersects the solid line of best fit. From that intersection point, look vertically downward to read the concentration on the x-axis. The intersection lies exactly on the fourth grid line, which corresponds to a concentration of 4.0 times 10 to the power minus 5 molar, since the major grid line is 5 times 10 to the power minus 5 molar and has 5 subdivisions. Each vertical grid line represents exactly 1.0 times 10 to the power minus 5 molar. Apply the stoichiometry of the complexation reaction. Look at the balanced chemical equation representing the conversion. Fe to the power 3 plus KSCN gives FeSCN to the power 2 plus K to the power plus because an excess of solid KSCN is added. The iron, 3, ion, Fe to the power 3 plus, is the limiting reactant and is completely converted into FeSCN to the power 2 plus. The stoichiometric ratio between Fe to the power 3 plus and FeSCN to the power 2 plus is exactly 1 to 1. Therefore, moles of Fe to the power 3 plus initially present equals moles of FeSCN to the power 2 plus produced. Convert the sample volume to liters. The volume of the sample is 100 ml. Converting to liters, L gives 100 ml times 1 liters over 1,000 milliliters equals 0.100 liters. Calculate the moles of Fe to the power 3 plus present. Use the molarity equation, N equals M times V, to find the total moles in the sample. Moles of FeSCN to the power 2 plus equals 4.0 times 10 to the power minus 5 moles per liter times 0.100 liters equals math 4.0 times 10 to the power minus 6 moles since there is a 1-to-1 ratio. The initial moles of Fe to the power 3 plus are exactly 4 times 10 to the power minus 6 moles, which identifies option C as the correct answer. The correct answer is option C, 4 by 10 to the power minus 6 moles.